Hello, welcome to HTM Hackers Hangout. It's September 7th. I'm Matt Taylor from Numenta. Thanks for watching. It's been a couple months since I've done one of these because it's been busy. I've had a vacation in the meantime, so that was part of it too. So thanks for joining us. Hi, Paul Lamb. We've got one of our community members online with us. Pipe in anytime, Paul. I'm going to go over my agenda, and then we can chat about anything you want. I don't have anything to show today. I'm just going to give a few sort of community updates. Sorry about the noise. I changed offices, and there's like a main street right down there. And sometimes ambulances go by. Sometimes people drive really loud cars. Anyway, community has been great. If you aren't a member of HTM Forum, go sign up because there's tons of discussion there. If you're watching this and you're not on HTM Forum, that's like the place to be to talk about HTM. Tons of conversations about really interesting things. We're doing a lot of discussion right now about the thalamus, which is one of the things that we're focused on in research, is trying to understand the thalamus and what role it plays in cortical processing and that cortical circuitry that we're always talking about. How does the thalamus play that role, especially between levels of the hierarchy, in between the cortex and the senses, that sort of stuff. Lots of discussion about that on the forums. About the thalamus, and that is like one of our big research areas. We have 2 papers coming out soon this fall. They're both almost done. I've read one of them, and the other one I'm working on it. So the first one, and I'm gonna do a post on this on the forum that kind of goes over our main papers. I think it gives a little summary of each papers and why it's important and how it builds on the previous one. So we've got like the neuron paper, which I think is the first important one to read, which explains the HTM neuron model and temporal sequence memory, which is like everything else builds on that. Then there's what we call the columns paper, which is like layers and columns, and introduces this idea of cortical circuitry and how the layers might communicate, and the idea of a location signal coming from somewhere. So the next one that we're working on, we're sort of internally calling columns plus. Right, but it takes where that one leaves off and gives software simulation and lots of details about it. So we talk specifically about what displacements are, how they can be applied to a set of grid cell modules to update them to a new location. So that we'll have simulations of that. I'll have lots of visualizations of that soon. There's some great graphics in this paper that I'm going to adapt into the next HTM school, 1 or 2 episodes of that. So you'll see this paper converted into video soon. That's one of the things I'm working on. But the paper's a bit, it's about locations in the neocortex and sensory motor object recognition with cortical grid cells. So the big idea is how we think grid cells work in the cortex for object recognition. And we will give concrete simulations and examples of that. So that will be in the Columns Plus paper. And if you like math, there'll be some math. So you'll be happy there. And including simulations. I haven't gotten to the simulations yet. Before this goes out, I'm going to be running all these simulations and testing them out and everything. So, but I haven't gotten quite that deep yet. I'm still working on understanding all of the graphics and the math. Math is a hard part for me, of course. So that's the Columns Plus paper. There's also another paper that we're working on. I forget exactly what it's called, but we're calling it the frameworks paper. And this is a more high-level paper. It's not the Columns Plus paper I just described is very detailed. Lots of, like I said, lots of math. There's code go along with it. This frameworks paper is going to be more of a high-level paper and describing, the system as a framework. And the idea, I think. And Jeff, we'll talk about this when it comes out. I mean, I'm basically talking to you, the community. Like, this is a small conversation. This isn't generally people out there in the public and on Twitter don't watch these hangouts. But for you guys, this frameworks paper is the way Jeff describes it as a framework is something that you don't know how the whole thing works. But we know one part over here has got to be doing something like this, another part's got to be doing something like this, and they got to be connected somehow like this, right? So the frameworks is filling in the things that we know about the brain and making sure that there's room for the other things that we know are happening, but maybe we don't know how. or we don't know how it's connected. We know something over here like this is happening. So putting it together a framework of not just cortical processing, but like brain processing, because like I said, we're talking about the thalamus now. We've studied a lot about hippocampus and around cortex that contributes to how we think things are working in the neocortex, obviously. So the frameworks is going to be much more high level. I don't think there's going to be any code associated with it, but I will probably still do an HTM video about this frameworks idea. So those are the 2 papers we're working on. Columns plus, lots of detail about locations in the neocortex and object recognition. Includes math, includes code. And the frameworks one, which is much more high level. So those will come out as probably similar times within the next month or 2. Jeff's got a bunch of speaking engagements this fall. We're trying to time the publication of these papers so that he can talk about them at these speaking engagements. We're hoping that there's a couple of journalists that come out with an article or 2 about Numenta sort of at the same time, because I really like this columns paper. I think you guys in the community that have been working on object recognition and how it could work are going to like this and are going to be able to dig into it and actually do some things with it. Although I haven't seen the code yet, I know Marcus and Scott have been really working on that code, getting it cleaned up, and Lewis, who's our main sort of applications engineer right now, is in the process of making sure that he can run it, and I'm going to make sure it's exposed to the public in a decent way with decent documentation and stuff. So that's my job there. So that's my update. It's all short and sweet, only 7 minutes or so, but we're working on papers. That's the main thing. As soon as those get out, we should have a nice flurry of activity this fall with these publications coming out, and some talks that Jeff is giving, and hopefully a couple of articles. So that's what's going on at Numenta. Sorry, I don't have anyone on the research team right now. Jeff's out of the office today. Got to take a break sometimes. But they have been really busy, and I really am liking the stuff that they're putting out now. Now that I see the papers going and them editing them, and I'm getting to read them, it's good stuff. So happy to see that. Now it's time for you guys. Paul, I know you're online. Do you want to talk about anything? And let me see. There's somebody chatting. Thanks for your work. No problem. All right. Any questions on chat? Throw it on chat if you don't want to join. Anything from you, Paul, ma'am?
No, I don't have anything. Mainly, I'm working on getting the NewPick core to work on 32-bit systems. So I've got a general idea of how I'm going to do it. I don't have it quite solved yet, but I'll post some stuff once I figure that out. So the main thing is I want to get it working on the Raspberry Pi. So
yeah, I know it's been done before, but I don't. It's been a while.
Yeah, it looks like it's fairly minor where it's having issues. So I believe I can solve it. So.
Okay, great. Well, thanks for your efforts, and thanks for being an important part of the community, Paul. I love your posts and your responses to people, especially helping out new people that are asking questions. I don't have time all the time to come in and answer them, and you've been great. You saved me a lot of time, so thank you.
Thank you.
Hey, Sam, you got anything you want to say?
Hey, Matt. Good to see you. Yeah, I just got this email. I was like, oh, they're doing one now. I like your long hair. I guess that's not too relevant to most things. Yeah, it's cool. I know you always have a cool hairstyle. Let's see. I would, maybe I'd ask a quick thing. So I'm being considered for possibly a job or internship where it's based on monitoring real-time video feeds, which is a thing. Obviously, it's a popular thing. And they talk a lot about like convolutional neural network, and we're gonna have like a team convolutional neural network. I know there was some stuff, as I vaguely recall, maybe this was back in the Zeta 1 days or something, where there was some use of HTM theory, at least sort of toward that. Or I don't know if there's, because they want to be able to like detect if there's a person in a certain place, or if there's, like a high sensitivity area. I don't know if there's been, I'll go and check the discussion stuff, but if there's any, I don't know, just anything that you know of in terms of maybe infusing HTM into that somehow? Does anything come to mind? I'll go and recheck the discussion or reread that old stuff, but just off the top, I don't know.
Well, two things come to mind. One is, yes, there was a Zeta 1 application that Vitamin D followed through to do object recognition within live streaming video. That was years and years ago, and I don't think I think SiteHound bought them, and I don't even think that they're using it in their products anymore, because now you can do it with deep learning probably easier, and everybody knows how to use deep learning, and not everybody knows how to use, especially that old version of HTM, which didn't include things like SDRs. So the hierarchy part was working well back then, but the basics weren't biologically correct. So that's why we sort of threw out the baby with the bathwater, so to speak, because that application does not really apply anymore to our current technology stack. That being said, and the other thing, I think it will eventually. I mean, we'll get to that point, but there is, and we talked about this at the Manhattan Hackathon a few years back. Frank Carey is an AI guy in Manhattan. His hack was like, okay, let's take a streaming video and run convolutional neural networks on frames of the video that can recognize objects within the frame, right? So they can do feature detection. You ever seen a video that says, there's a duck in here, and there's water, and there's trees, or something like that?
Right.
If you can, and this is an old idea, I don't know if anybody's ever done it, but if you can take that sort of output and treat that feature array, like whether something exists in the scene or not, as an SDR, and then have basically deep learning do your feature detection, but for every frame of the video, have a new SDR that tells you what's in the frame, like what features exist in the frame. And then you should be able to, over time, especially if you're encoding time along with these features, you should be able to predict what features will be in the frame at different points in the future. So that's an idea.
Another way that I've
successfully do that, but theoretically that should totally work.
Yeah, another way that I've sort of married deep neural networks with HTM is basically usually get an output, like you said, where you've got the percentage of this concept being present is X%. The percentage of this is X%, right? It's usually it's not ever 100%. You always have 90% or 2% or 36% or whatever. Then take the word fingerprints from cortical.io. And so you sample that percentage of those SDRs, stack them up, and then basically do a sparsification step where the same bit, basically the bits that appear more often, those have a higher precedence over bits that don't appear as often. And so you do a sparsification and you generate a SDR for that timestamp. And so then you can run that through temporal memory or whatever. And that'll pick up things like, say a cat passes by frequently, and then a dog passes by. That's going to have a semantic similarity, right? So you can do a lot of cool stuff with that.
So, wow. So let me recap, because that sounded really interesting. So take those words you're saying and get the actual cortical.io encodings for the words, union them together, and then somehow take a sample of that, so you get not just features.
Yeah, it's more than just a union. You need to know. It's sort of like if you look at the videos on cortical.io and on how they make fingerprints for phrases, it's the same concept. You count if three SDRs have the same bit, then that gets a count of 3, and that's going to have a higher precedence. You're going to pick that one before you pick one that has a count of 2, for example.
That's smart, because you'll
pick them up to whatever sparsity level you're looking for.
Yeah, and you should get representations of object features that way, not just objects that the neural network, that the deep learning part identifies. Yeah. You'll get actual understanding of features of objects. So like you said, if there's a dog and a cat both in the frame at the same time, you should have more furry bits, right?
Yeah, exactly. Or, a man walks by at 2 a.m. every day, then a woman walks by at 2 a.m. another day. You're going to see you're going to see a semantic similarity, but it's not going to be exactly the same. So it's the same kind of a concept here, where you've basically taken the work that cortical.io has done to relate words together, and then combine that with what you get on your output of your image analysis.
Cool. Did you guys hear that? It's a free idea. That's a good idea.
That's great. I don't suppose that That's like written anywhere or anything? Like, did you just kind of like think of that, or because yeah, that sounds great to me. I'd love to. I think
I
I get
have
the
some code somewhere I can clean up, probably put it up on GitHub if you're interested. So yeah.
Yeah, I'm not here to give you any more work to do, but if you're so inclined, I would definitely check it out.
Cool. Yeah, I'll do that.
Security footage where you only get like one frame every 10 seconds or something. Yeah.
I haven't done it on video specifically, but I've done it for other image analysis problems. So I think it could be applied to video, I think. So
definitely, yeah, I think so. Cool idea.
Thank you. I appreciate that, and yeah, very cool. Yeah, if you happen to feel inclined to do that, I'll totally have a look at that, because yeah, it seems like you could use like some kind of pre-processing with deep learning or something to get, the idea that to extract like, oh, that's a person, and then, involve the richness of HTM could really add on to that. So I'd love to be able to bring that as a, as a thing maybe to this company, or at least understand how I could. So anyways, thank you. And yeah, I would just second what he said, Paul. Your posts are always really cool. I like how you jump on helping out new people and stuff. I try to do that a bit, and you're usually right there. So anyways, glad to have you there, of course. And Matt too, the flag bearer. So anyhow,
Sam, you've been real helpful too. So I appreciate everybody.
Yeah, try to step in where I can. But yeah, and thanks for making me a regular too. I was proud of that.
Hey man, I didn't make you a regular. The forum did it. So you've been around long enough that you're just naturally a regular.
Oh, okay. Like just automatically, or through some kind of
it's got all these rules about how it creates trust levels. So you're at now like trust level 3. So you have more permissions to do stuff. I think you can edit topics, and if you see a misspelling, you can just change it.
Oh, cool. All right. Wow. I feel powerful. Cool. As I gotta get going myself, but thanks so much for the idea. And yeah, and I'm excited for the new papers, and yeah, very cool. Thanks a lot.
See you, Sam. Last chance for questions via chat before we log off. Get them in there quick if you have any. Otherwise, I see we have a new visitor there. Andrew, if you have anything to say, now is the time. We're just kind of wrapping up.
No, all good. Sorry, I'm late.
That's okay. No problem. It was sort of short notice. I mean, I have it on the calendar, but sometimes I forget about it until I get in the office. And last week was part vacation. I went to a music festival, so I was a little distracted.
Cool. I'm more of a lurker anyway, so no questions from me.
All right, no problem. Thanks for joining. Nobody's asking questions in chat, so I am going to sign off. Thanks everybody for joining today's HTM Hackers Hangout. See you in a month. See you on the forums. If you have any questions, contact me there, or just ask the question on the forum. It's the best thing to do. If you're worried, like, I don't know if I should put it on, just put it on the forum. If I don't like it, I'll move it. There's someone says, oh, hi, David. David's online. Hi, he said hi. David Cognition, our Java guy. And then someone had a question about any similarity with Vicarious. So Vicarious, no, I guess, I don't know what they're doing at Vicarious. They don't share too much about their technology, but I can say that Dilip George, who's the founder of Vicarious, used to work for Jeff at Numenta. I think that was like a long time ago, 8 years ago, something like that. But he left to form Vicarious. They're using more standard machine learning techniques like Bayesian inference, Bayesian prediction, stuff like that. We don't use any Bayesian techniques at all. We focus on neurons and how they're interacting. So that's the big difference. Numenta is focused on biology, how do neurons interact with each other at the neuron level, how do populations of neurons interact with each other. And we're paying really detailed attention to those interactions. Whereas you do like Bayesian learning, you kind of fuzz all that out. That's a big black box. And you're looking at more of the population effects, in the box, what's happening. And that's more the approach Vicarious is taking. We want to understand intelligence. We want to know how it works. We don't just want to model and simulate it, which I think is more of that approach. So hopefully that answers the question. And also, we're very transparent and open about everything, all of our code and everything. Vicarious is not. I think their technology is proprietary. Another question on chat. He mentioned about recursive cortical networks in the recent AGI conference. Oh yeah, delete. Yeah, I saw somebody said something about on the forum about that, but I don't know anything about their current technology. But I don't. But like except what I just said. So, all right, I'm gonna sign off, you guys. What up, Daniel? See you guys later. Hit me up on the forums. Bye.
Bye-bye.